Okay, hi guys. Trig limits, that's our topic for this video. They're pretty fun. So, trig limits, the first step to them is usually you try and plug the value in first. 90% of the time it's going to work. So it's the good old-fashioned plug and chug. Substitute the limit value in, see if it works, gives you an answer. It should most of the time. If it doesn't work, the backup plans that we use normally, like factoring, distributing, the conjugate, they can sometimes work, but with trig problems it's not as common. The most common thing for a trig thing is you go looking for, I'm going to write look for, the kingpin. And the kingpin's just like a fun little nickname for a certain limit that we kind of commit to our memory. It's the limit as x approaches 0 for a sine function. And it's really particular. It's when it's in a fraction over x. So it could be the sine of anything, sine of 3x, sine of 10x, sine of 12x. So we say ax. A is just any number. And on the bottom it could be b times x. It could be 5x, 6x, 7x on the bottom. The answer to this limit is always going to be a fraction of a over b. And there's this real fun, nice proof that shows you why this is true. But it works every single time as long as it's the limit as x goes to 0. You have to pay close attention because if it's x goes to 1, this whole idea of a kingpin is out the door. So it's got to be x goes to 0. So with trig limits for our class, you always want to try and plug and chug first, and then if that doesn't work, go looking for the kingpin if it's x goes to 0. So I'm going to give you a couple of examples and talk about these a little bit. Let's say I gave you the limit as x approaches 0, and I gave you something like cosine of sine of x, some sort of composite function. Well, it does go to 0, so we could look for a kingpin, but I don't really need to. I can plug and chug first, and if I plug in 0, I'm going to have cosine of sine of 0. It's nice, I don't even have a fraction involved. So think about your unit circle. Know your unit circle really well. Here's 0 over here. The sine at 0 is going to be, this is 1 comma 0. So cosine and sine. So we're looking at, this whole thing is 0. So we have cosine of 0. And the cosine at 0 is 1. So the answer is 1. That's our limit value. So like I said, plug and chug whenever you can. Here's an example of a problem where you can't do that. Next example. Let's say you had the limit as x approaches 0, and you got this thing. You got sine squared of 2x over x squared. You're not going to plug 0 in for this one because you're going to get 0 squared. That's not going to work. D&E. But it's not D&E. It's a kingpin problem. It's just not in kingpin format, which means kingpin format. That sounds so technical. Okay, so really it just means, let's rewrite this. The limit as x goes to 0. We know what sine squared means. It means sine times sine. So I'm going to rewrite it as sine of 2x times the sine of 2x. Can you guess what the common mistake on this problem is? It's confusion over the inside piece. Sine squared means the whole thing is squared. It means sine 2x times sine 2x. People get thrown off by that, amazingly. They're not sure what to do with the 2x usually. X squared means x times x. So what we really have here is we've got two fractions being multiplied. They're both kingpins. This is a 1x and this is a 1x. So this kingpin is 2 over 1. This kingpin is 2 over 1. And 2 times 2 is 4, so my answer to this problem is 4. And I got it. So that's kind of a typical problem, something with a sine squared. Another typical problem would be something like this example. Let's say you had, that's a good example. How about this? How about limit as x goes to 0? And you get 3x plus the sine of x all over 5x. I don't know. You can't plug in 0 because you get 5 times 0 is 0. But I see the king, I mean it's right there in front of me. I see the kingpin, I know I can go with that strategy. It's an adding problem, so I'm going to break this fraction apart. I'm going to say limit as x goes to 0. An adding problem, split the fraction apart, we have common denominators. We're going to have 3x over 5x plus sine x over 5x. That'll be my setup, which is really kind of nice because these cancel, and I just get 3/5. Plus, this thing is just a kingpin. We've got a 1 over 5, so 1/5. So 3/5 plus 1/5 is 4/5. There's my answer, 4/5. So just a little bit of work. You got to tweak the fraction, move it around a little bit to find that kingpin. Some of these kingpin ones are not as easy. I mean, this I did in, what, a couple of steps, 2 steps or something. There's some that take a lot more steps, so we'll have to look at some harder ones. Let's do an example of one that gets people a little more confused. So, example. How about we do this one, the limit as x goes to 0. And you get sine of x all over x plus tangent of x. It's a fun one. So you can plug in 0. Oh, sorry, I keep moving this around. You can plug in 0, but the whole denominator is going to be 0 when you're all done. So it's not going to work. So instead, I'm going to break this fraction apart, split it up. I'm going to do the limit as x goes to 0. I'm going to make it sine of x all over 1 times 1 all over x plus tangent of x. That'll work out better for me. And I see, like, now that I've split it apart, I see a sign kind of isolated by itself. It's not a kingpin because there's no x down here, but I would really love for there to be an x down here. So how about I write one in? It'll make my life easier. If I write one in, you can't just randomly put an x there unless you counterbalance it. Put an x up here because mathematically they cancel, and I haven't done anything technically, but I now have a kingpin. So watch what I'm going to do next. I'm going to write the limit as x goes to 0. I'm going to take these 2 kingpins and turn it into one giant fraction. So I have sine of x all over x, and instead of writing times this fraction, I'll divide the whole thing and flip the fraction over. So x plus tangent of x all over x. It's hideous. I mean, it's this big double fraction stacked on top of each other. It's not very nice. But the whole top is a kingpin, so I already know this whole entire thing goes to 1. And I'm going to rewrite it. Limit as x goes to 0. Big fraction. I know the top's going to be 1, so why don't we just write that? Make it less confusing. The bottom, split it apart. Make it x over x plus tangent of x over x. Split that fraction up. X over x cancels to 1. So I have the limit as x goes to 0. Big fraction. I have 1 over 1 plus, and I'm going to change tangent. I'm going to change tangent to sine over cosine. So sine of x over cosine of x all over x. It's still ugly. This fraction is still really bad, but it's getting better because I'm going to move this fraction around. Limit as x goes to 0 of 1 over 1 plus sine over cosine. And I don't want the triple fraction, so instead of writing over x, I'm going to write times 1 over x. And then do you see the other kingpin that's kind of hidden in there? It's right there. Another kingpin. So I'm going to move this around so it looks a little better for me. Limit as x goes to 0 of 1 over 1 plus. Flip this around on bottom. Make it sine of x over x times 1 over cosine of x. We're finally getting close to an answer. This is another kingpin. It's going to go to 1. This little piece that's left, I'm going to plug in chug. So what I'm going to get is, let's plug in chug and clean this up. I'm going to have 1 over 1 plus the kingpin, which technically is 1, times 1 over cosine, and I'll plug in 0, so cosine is 0. So as long as we know the cosine is 0, which is 1, we should be able to clean this up. So we have 1 over 1 plus 1 times 1 over 1, which is 1 plus 1 is 2, so 1 over 2 is 1/2. Oh, sorry. And there's my answer. So a really good example of how looking for the kingpin, I mean, this took me a whole page of notes. I wrote big, but we started way up top here. So you have to break these fractions up and just go looking for that kingpin, split it up. Use what you know, use your algebra skills to kind of break it down. This was the weirdest part, is having to force that x in to make the kingpin. So we'll definitely be practicing a lot of that in class. So hopefully that helps. Maybe I'll post another video on trig limits if I get around to it soon.